In today's lesson, we are going to review our exponent laws. So this is something that we did cover, you should have covered in grade 9. You may or may not have reviewed it a bit in grade 10. So you may not remember this exactly, but hopefully as we go through it, it does tend to be a little bit, or does kind of come back to you. So I'm just going to do a little review. In class, we're doing whiteboards for this. But if you're working on this on your own, again, you can just try to answer the questions. So if we want to expand this and simplify. So expand means to multiply or really show what does this actually mean. And then simplify, we're just going to make everything a lot better, or a lot simpler, smaller. So if I look at 2 to the power of 3, what does that actually mean? Well, 2 to the power of 3 means 2 times 2 times 2. And then that's going to multiply 2 to the power of 4, which is 2 times 2 times 2 times 2. And this I can simplify. So I've expanded it here. I can simplify this because I have 1, 2, 3, 4, 5, 6, 7 2's all multiplied by each other. And a simpler way of doing that is just saying 2 to the power of 7. Here it's the same idea. 3 to the power of 2 means 3 times 3, multiplied by 3 to the power of 3, 3 times 3 times 3. Simplifying it, well, I have 5 3's together, so I can say 3 to the power of 5. This one might be a little bit different, because we have 3 things, but the same idea still applies. We have a 4. We're multiplying it by 4 to the power of 5, which means 1, 2, 3, 4, 5. 5 4's, and then we have 2 4's. If I simplify this all together, I should have 8 4's, so I can write it as 4 to the power of 8. What about if we switch it up and divide? Right, this one, if I want to write it out, I could say 6 times 6 times 6 times 6 times 6 divided by 6 times 6 times 6. So I'm just writing it a different way. If I'm multiplying by 6 and dividing by 6, it would cancel out. So I can cancel out actually that. And I'm left with 2 6's, which is the same thing as saying 6 to the power of 2. Here we have it written out differently as a fraction. Still means division. I can rewrite this. 7 times 7 times 7 times 7 times 7 divided by 3 7's. So similar to what we had, I can cross out 1 on the top, 1 on the bottom to cancel out. I have 3 7's left over, 7 to the power of 3. I have the same thing here, so we're just going to skip this one. We'll go to a different one. Here, this one's a little different. Now we have 4 to the power of 2 to the power of 3. How can I expand this? Well, the power of 3 tells me that I have 3 4 squareds all multiplied. And then 4 squared is the same as saying 4 times 4 times 4 times 4 times 4 times 4. And this can be simplified to 4 to the power of 6, because I have 6 4's all multiplied. With this one, 8 to the power of 4 to the power of 2. Well, that means I have 8 to the power of 4 twice. And what would that simplify to? Well, if we go through 8 to the power of 4, that's 4 8's. And we multiply that by 4 more 8's, which I can simplify then to 8 to the power of 8, because I have 8 multiplied by itself 4 times. So what we're looking at are exponent laws, and hopefully you recognize some patterns as we went through those kind of warm-ups, and because we're going to look at some of the laws, so some of the ways to easily work or simplify powers. So when we're multiplying powers with the same base, we add our exponents together. So b to the power of n times b to the power of m equals b to the power of n plus m. So we add our exponents in this case. When we're multiplying powers, we add our exponents. When we're dividing powers, we're going to subtract. B to the power of n divided by b to the power of m equals b to the power of n minus m. So we're dividing powers, we're going to subtract our exponents. And finally, the last law we're going to look at today is to simplify the power of a power. B to the power of n times m, b to the power of n to the power of m, we multiply our powers, or our exponents. So let's look at some examples. So we have 10 to the power of 5 times 10 to the power of 7 divided by 10 to the power of 4 to the power of 2. When I have something like this, a fraction like this, I want to simplify the top and the bottom separately and then worry about that division. Because again, remember, fractions indicate division. So 10 to the power of 5 times 10 to the power of 7, that's multiplying powers. I'm going to add my exponents and get 10 to the power of 12. On the bottom, I have a power of a power, so that means I multiply my exponents, 10 to the power of 8. Now I have a division. Division tells me I have to subtract, so I get 10 to the power of 4. 12 minus 8 is 4. And then if I wanted to, I could evaluate or get a final answer for that. Next one, same idea. Let's simplify the top first, and then the bottom. We do want to kind of use BEDMAS or deal with power of a power first. So do power of a power first when we have multiple things to worry about. So I'm going to take care of this power to the power here. 4 to the power of 3 to the power of 6. I multiply, so I have 18. That's still then multiplied by 4 to the power of 2. On the bottom, I can simplify that because I'm not doing anything yet. So 4 to the power of 3 multiplied by 4 to the power of 5 gives me 4 to the power of 8. I'm adding. Next, the top still needs to be simplified, so I'm multiplying on the top, so that's 4 to the power of 20, or 8 plus 2, divided by 4 to the power of 8. Now we're subtracting because we're dividing our powers. We get 4 to the power of 12, which is our final answer, or a simplified answer. Same idea for the next one, just different type of example. Let's simplify the top and the bottom separately. So on the top, we just have multiplying, so 2 to the power of 12. On the bottom, let's focus on that power of a power first. 2 to the power of 4 times 2, or 8, multiplied by 2 to the power of 2. We have 2 to the power of 12, then divided by, we have multiplying powers, so let's add our exponents. 2 to the power of 10. This gives us then subtraction, because we're dividing powers. 2 to the power of 12 minus 10, which is 2. What would happen if we had fractions as our base? So 5 thirds to the power of 4. Well, similar to last time, let's break it down and see what does this actually work out to. Well, 5 over 3 to the power of 4 means I have 5 over 3 times 5 over 3 times 5 over 3 times 5 over 3. I can then simplify this because by multiplying powers, I multiply the numerators together and I multiply the denominators together. So for my numerators, I would have 5 times 5 times 5 times 5 over 3 times 3 times 3 times 3. This looks similar. I can simplify this. 5 times 5 times 5 times 5, or 5 times itself 4 times, is the same thing as saying 5 to the power of 4. 3 multiplied by itself 4 times is 3 to the power of 4. So if I have a fraction raised to an exponent, that exponent applies to both parts. Applies to both the numerator and the denominator. So when we have a fraction, the exponent applies to both parts. The same rules apply when we're going through this. So even if we have a fraction, the same rules apply. They have the same base, or the same fraction base. I'm multiplying, so I'm going to add my powers, or my exponents. So I get 3 over 2 to the power of 5 plus 2, which is 7. I could simplify this to 3 over 7, or 3 to the power of 7 divided by 2 to the power of 7. Or I could leave it as 3 over 2 to the power of 7. Same thing. This would allow me to evaluate it as a fraction, though, because I can easily calculate this part on my calculator. 3 to the power of 7, I get 2,187 divided by 2 to the power of 7, which is 128. Right, so in some cases, if we want to leave it as a fraction, we don't want it as a decimal, because if you did 3 divided by 2 to the power of 7, you would get a decimal number, right? Because this one would work out to 17.086. And there's more values, I'm rounding it. So again, sometimes it's nicer to leave it as a fraction. Next one, same idea. Same base, I'm multiplying powers together, so I'm going to add my exponents. 1 over 9 to the power of 5. If I wanted to evaluate this, I would say 1 to the power of 5 over 9 to the power of 5. 1 to the power of anything is just going to equal 1. 9 to the power of 5 is 59,049. So that would be my simplified or evaluated answer. So again, the main thing from this one is just recognizing those kind of 3 basic laws. Those laws should be reviewed from grade 9. So if you don't remember them, hopefully it does kind of ring a bell now. If you're ever stuck, though, feel free to always expand your answers and then simplify from there. Right? So that was what we did in the review at the beginning. It does help when you're writing it out neatly, so that you don't have multiple values or put extra values. Or when you're canceling out, you make sure you cancel out the correct number. So you could work and expand similar to what we did going all the way back up to here, right? So you could expand it fully and then simplify it to get your final answer. But the rules or the laws do make it easier. So when we multiply powers, we add the exponents. Divide powers, we subtract the exponents. And power of a power, we multiply exponents. So it is easier to use the rules, less work, and it's kind of the shortcut. But if you need to expand and do it the long way, that does work. It obviously just takes more time and there's more chances for possible errors.